Welcome back to DesignSpark channel. As our first video for 2021, we're bringing another unboxing video to you. My name is Kamilla and the product we'll be unboxing today is Semiconductor's RSL10 Mesh Platform, which is based on ultra-low power RSL10 Bluetooth Low Energy system-on-the-chip model. This kit enables the users to develop their Bluetooth mesh networking applications that can range from home automation, asset tracking, predictive maintenance, and much more. In this video, we'll show you what you'll get when you order the kit from us and demonstrate how you can easily get started with building mesh networking topology for your application. The development kit consists of two RSL10 based mesh nodes with multiple environmental sensors, a Strata Gateway node which enables connectivity to the Strata Developer Studio, as well as 3 USB cables and the ring magnet. To power the nodes, you can use a battery or power directly from a 5V rail by adjusting the location of the jumper across a 4-pin header. If you choose the first option, make sure to select the battery from recommended list provided in the user guide. I'm going to be using a USB hub and power from my PC. Let's have a look at the different components of this platform a bit more closely. Starting with the RSL10 system and package, as you can see, it's the heart of both mesh nodes and gateway node. The SiP itself integrates RSL10 system on chip, antenna, and as well as all the passive components. The chip is based on Arm Cortex M3 Processor and a 32-bit digital signal processing core. It supports Bluetooth Low Energy technology and 2.4 GHz proprietary protocol stacks, all while not compromising on power consumption and size. Moving on to the sensors, each node contains low voltage digital output temperature sensor as well as ambient light sensor. Both of these sensors communicate with the RSL10 using I2C communication protocol. The third type of sensor present on each mesh node is Honeywell's magnetic field sensor, which utilizes anisotropic magnetic resistance or AMR principles to detect rotational movement, which is useful for applications such as dimming that are prevalent within the IoT environment. And this sensor is followed by a chopper stabilized op-amp to amplify the signal from the sensor. And lastly, each node features Hall effect sensor for simple operations like magnet detection. Each mesh node also features dual RGB LEDs, LED driver that can support 5-bit current controlled dimming, as well as 2.3 kHz tone indicator. An optional tactile buzzer from Adafruit can be added to this board. Some of the other components that are present on the board are load switch for overcurrent protection, lithium-ion single-cell battery charger with a fixed float voltage of 4.2 volts, as well as an LDO regulator that can provide 2.8 volts that is necessary to power the RSL10. Now, for more exciting part of the video, let's go to Strata Developer Studio and run a few simulations to explore all the possibilities of this platform. Let's start by opening Strata Developer Studio and logging in. Then connect USB cable to the gateway node. Control view will be automatically loaded after the board is detected. And once gateway is initialized, LEDs on gateway node will turn green. In the Strata Developer Studio, you have an access to the relevant documentation, including guides, schematic, board layout information, printable templates, as well as datasheets and software downloads. It's a good place to get started if it's your first time experimenting with the platform. Going back to the control view, let's now try to provision the server nodes. Once both nodes are powered, LEDs will light up blue, and then the color eventually will change to pink or light blue after these nodes have been provisioned, depending on the address that was assigned to them. This will take a few seconds, but make sure to wait until the nodes dim down, since that indicates that the application key binding to the models of the node has finished correctly. You can also monitor the status of these nodes in the node communication pane on the right side of the panel. In this example project, each node corresponds to various locations within the office environment that needs to be monitored. By dragging and dropping the nodes, we can allocate them to specific locations we're interested in. For example, I can allocate the node 2 to security cameras, and if I click on the small circle in the UI, the color of all mesh nodes change to the color at this location, which in this case is pink. Another scenario we can test is to check if the door has been left open or not. If I assign the node 2 to the door, the mesh node will enable the magnetic contact to detect any magnet underneath it. I'm using the printable template to perfectly align the magnet with the node. If there is no magnet, the alarm is activated and the red lights will flash until the magnet is detected or the timer runs out. Apart from these two examples, you can also experiment with other node locations such as doorbell, dimmer, robotic arm, solar panels, and more. You can also venture towards the smart home environment and explore 3 more mesh node locations such as the door, windows, and the lights. For more detailed instructions, follow the user guide.
And this is end of today's video. Thank you for joining me, and I hope to see you next time. Bye.